Welcome back, Tuesday morning. We're going to begin lesson 34, which is called implicit differentiation. So, I think I spelled that correctly. I don't even know. I hope you guys are doing great. We're going to review just a little bit because this is something a little new, but it takes off of things that we already know, okay? So, first things first, implicit differentiation. So, what's different than what we have been doing? Okay, so I'm going to give you a few scenarios. In general, we do explicit. Okay, explicit means we have solved y equals. Okay, whatever function you have it y equals. Y equals 5x squared plus 2x minus 5. Okay, and if we want to do explicit differentiation. Now, let's review what in the world is differentiation. Do you remember? We've kind of reviewed a little bit. Differentiation or differentials is really what we've talked about, is solving for a dy. Okay? So maybe we've taken a derivative, dy dx, and I'm just going to use this same example. The derivative of y would simply be 10x plus 2. Okay? To define the differential, we would multiply both sides by dx, correct? So those dx's, so we have dy equals 10x plus 2 dx. This is a differential when they just want dy by itself. Okay? Explicit means you only have one variable on one side and another variable or variables on the other side. Whatever you're trying to find, y to dy is all by itself. Okay? That's what we've known. That's what we have done. Okay? Now I'm going to give you a scenario, which I know that you would recognize this, and you could solve it if you had 2x plus 5y equals 12. Okay, now that's a pretty easy equation, and we could solve very easily for y by itself, correct? We could subtract 2x, so we would have 5y equals 12 minus 2x, and then we could divide by 5. Very simple problem to find y by itself. Not a hard one, okay? And then we can find the derivative of this, or the differential of this. Not a big deal, okay? Going forward, and why we will want to use implicit differentiation is to say, hey, it's really hard for me to solve y equals, and then what I get by itself, that's going to be really hard and yucky to take the derivative of, okay? So this one is not hard. We have a 12 over 5 minus 2/5 x. Not a hard one to solve and get the derivative of, okay? Not going to do it. We don't have to do it, but I know you want to. That's okay. So if I have this equation, y equals, what is dy dx? Okay, what's the derivative of 12/5? That's right, it's 0. And then our x, negative 2/5 x to the first. What's the derivative of that? Correct, 2/5. Okay, so if I wanted dy, what will dy equal? Yeah, 2/5 dx. That is our differential. Okay? All right, so now let's talk about implicit differentiation. Implicit means it's going to be harder. X squared plus y squared equals 9. I know you all recognize that. It's the equation of a circle, right? It is. It's wonderful. But if I wanted to solve for y squared, I would subtract x squared, but then taking the square root and having to deal with that, they're like, wait, don't do it. Okay? So what we're going to do is we're going to take the derivative, actually we're going to take the differential of every piece by itself. Okay? So when we take the derivative or differential, so what's the derivative of x squared? 2x. Now, if you noticed before, if I'm trying to find x squared, if I want the differential, it would be 2x dx. Okay, because there was a dy dx over here. If this was a y equals. Let's don't use y, because I've already got a y. Let's say z equals. So dz dx, but now I'm going to multiply both sides. Okay, so it would be 2x dx. That's the differential of that first piece. Okay, so what about the second piece? If I say w equals y squared, what is dw equal to? The derivative times what did you take the derivative of based on? It would be dy. These two variables must match, the y and dy, the x and the dx. It's the variable in which you're taking the derivative of. Okay? So here we go. We've got a 2y dy equals, what's the derivative of 9? What's the derivative of any constant? Yeah, it is 0. Okay? Now, if we wanted to solve for the derivative, what if we wanted to solve for dy dx? Could we do that? Yes. I'm going to tell you a trick. What we have in our denominator, we want to divide every piece by dx. Okay? So that if we divide this piece by dx, this piece by dx, even that piece by dx, we know it will be the same, we will get a fraction that is our derivative, dy dx. Okay? This dx divided by dx is, guess what? Simply a 1. Okay? So we're going to reduce. So we'll have 2x plus 2y dy dx equals 0. Now I want to isolate my derivative and solve for dy dx. All right, so we're moving everything else over. We're going to subtract 2x. So now we have 2y dy dx equals negative 2x. I'm going to scroll down just a little bit. And then we're going to solve for dy dx. So how are we going to solve for that? We're going to divide both sides by 2y. So when I divide by 2y, I still have a negative sign. 2 divided by 2 is simply 1. So I have a negative x over negative y. You now have the derivative, dy dx, of our circle. X squared plus y squared equals 9. Okay, I'm going to scroll back up so we can see maybe both of them in the same one. Yes. So the derivative of our circle is simply negative x over y, whatever points x and y are. A little hint, that 9 didn't even matter. Every circle will be this answer, the derivative, okay? So let's start some other examples. Okay. Let xy plus 1 equal 2x minus y. And they want you to find dy dx. Okay? First step, always the same. Okay? Let me write that somewhere. First step, always, is to take, probably a better word would be find. is to find the differentials of every piece, of every single term. Okay, so how many terms do I have? We have 4. Okay? What I will give you a huge hint on, sometimes everything that we've already learned can come back to haunt us. Okay? See that xy? Is that just the derivative of x and times the derivative of y? No. That is what? A product rule. Okay? You can't forget. The product rule is going to start showing up in some random, crazy places. Okay? So here's your first piece. So finding the differentials. And this is going to take quite a bit of space. So I'm going to go to the left and every time with product rule, I'm going to go with u and a v. My u is x. My v is y. My du, because we're doing differentials, I'm just doing du. Derivative of x is 1 dx. The derivative of v, or the differential dv, derivative of y is 1 dy. Okay, that's differentials with the product rule. Okay, so now I'm going to come down each piece. What is the derivative or differential of product rule? First, d second, plus second, d first. Okay, first, d second, so I've got an x dy, because I really am not going to put that 1 there. It's not necessary. Plus, what? Second, d first, y dx. Differential of 1, oh, that's 0. Okay, equals, now what's the derivative or differential of 2x? Okay, what is your differential of 2x? If z equals 2x, what is dz? What's the derivative of 2x? 2. All right, it's only 2, but I need that dx. Okay, so we've got a 2 dx minus, what about the derivative of y? You're right, it's 1 dy. Okay, because we really just did it up here on this one. Okay, next, we are solving for dy dx. So what do we need to divide everything by? Your second step, after you've found all the differentials, will be to divide by whatever is you're dividing by here. A little hint, that will change. It will not always be dy dx. Okay? We could solve for dx dy. Okay? So watch out, it will change. So now I'm going to go back and divide every term by dx. Okay? Some will simply cancel. They'll be 1. We're happy about that. Go ahead and mark those out. So after I do that, I've got an x dy dx plus y equals 2 minus dy dx. If you want a second step, if there's a first step, let's go ahead and make a second step. Second step will not always be the same. Well, kind of. You're going to divide by the denominator of what you're looking for. Okay, so we've divided by dx, our second step. Okay, then you're going to simplify. If we even want to go and say, hey, then simplify. Third, simplify. Okay, we've already done that step. Scrolling down. Next, we need to get all our variables together on one side, okay? Really, I probably would say fourth, solve for what you want. It will take some algebra. Okay, it will take some algebra. So we want to solve for dy dx. But this time, I have two of them. So I need to get them together, right? So we're solving an algebraic equation. I've got two x's or two unknowns that I want to solve for on each side. What do we do with it? Now, I'm going to add dy dx to both sides. So that's going to cancel that out. Plus dy dx. Okay, what about this y and that 2? Well, I want to get those together on one side. So can I subtract y and take it to the other side? Okay, so it's going to look something like this. X dy dx plus dy dx equals 2 minus y. Okay, so I've moved stuff from the right to the left and from the left to the right. Okay, now I need to, how do I solve for this dy dx? They're together on one side and there's two of them. So can I factor out a dy dx? Because I have two terms and there's a dy dx in both of them. Can I factor it out? That answer is, of course you can. When you factor it out, what are you left with? Well, the only thing on the outside of this one is x. What about on the outside of this one? What is dy dx divided by dy dx? There's a plus 1. Don't forget that, plus 1 equals 2 minus y. Now, pretty simple. There's a dy dx on the outside of a parentheses. How can we solve for dy dx? Divide by what else is with it, right? Divide by x plus 1. Those cancel, and now we have 2 minus y over x plus 1 equals dy dx. Okay, we have solved. Okay, it's going to be following algebra steps. So the first step will always be every time take the differential of every piece. Second step, sometimes you're going to have to do the product rule, sometimes you're going to have to do other things. To do that, second step will be divide by the denominator you're looking for. Third, we will simplify. When you divide, some things will cancel, okay? And then fourth, we're going to solve. Solve for what you want by itself, okay? Let's do one more for sure. If you're given that y squared minus xy equals sine x, okay, and both functions x and y are functions of time, okay, can you find dy dx? So we're going to start with that. And again, I hope you see, hope they don't trick you by putting product rules in there. Okay, does everybody see a product rule already? Yes. It's okay. Don't let it trip you up. It's going to be there. All right, so here we go. Taking differentials. I'm going to start going a touch faster, but not too fast. Derivative or differential is 2y. What did you take the derivative based on? Y. Okay? We just did one with an xy, but still, I am that crazy person who is always making a u as x and a du is 1 dx. Derivative. V, or differential, is y. dv is 1 dy. Okay? I do that every time. Makes me not miss them. Okay? So I'm going to subtract just because that, now a little hint, I'm going to put a parentheses because that subtraction is on the outside of my product rule. Okay? Because I didn't say x was a negative. I didn't put that negative here, okay? So I'm putting it on the outside of my parentheses. That will change stuff. So here we go. First, d second plus second, d first. That's my product rule. Equals, what's the derivative of sine x? Yep, you have it. It is cosine x. Now, that was my first step. My second step is going to be to divide. And as I divide, I'm going to distribute this in here, and I'm going to divide by dx every time. Oh, yeah, you saw it. I totally forgot to put my dx there. You saw it. I know you did. You're the same as Evans. What about the dx? Didn't you take a differential? Yes, I did, and I forgot about it. Biggest mistake that I make that I hope you don't make, okay? Then I'm going to start reducing. I can't reduce anything till here and there, okay? So here we go. I have a 2y dy dx minus x dy dx minus y equals cosine x. Because I distributed that negative sign and divided by dx all at the same time. Well, here at least my dy dx is on the same side of the equation. I don't have to take it anywhere else. But I do need to add a y to both sides. Okay? So if you feel confident, feel okay, you can do this all in one step. Go ahead and factor out that dy dx. And then I have a 2y minus x equals cosine x plus y. Hope I'm not going too fast. It's okay. You can tell me to slow down, but I probably won't hear you just yet. Sorry, I just had a thought. Sawyer was watching a video. He's having to watch these videos online. And they're like, a guy asked a question, and he replied with a different answer. And the guy said, "You're correct!" And he told the other one, and Sawyer was like, wasn't correct. So it was kind of funny. Sorry. Side note, can't still take it away. All right, so we're going to divide both sides by 2y minus x. So this piece right here equals my dy dx. Okay, we've solved dy dx. They also ask, well, can you solve dx dy? Could we solve this for dx dy? I don't think I used green here. So I'm going to make a new problem. And we're going to solve for dx dy. Now, if you've already found the differential, I'm starting with that line right there. 2y dy minus x dy. I'm going to go ahead and distribute because, I don't know, it doesn't really matter. Cosine x dx. We've already taken the differential. If they're asking you this question, don't make it any harder than it actually is. I know I already am if you've already figured this out. But no matter what they're asking for, we're taking the differential. That's our first step. Next, if they're asking us to divide dx dy, then I'm going to take this and just divide by dy. dy. Okay? Cancel, cancel, and then I have to do some rearranging. Okay? So I'm going to go ahead, I'm going to dx dy here and a dx dy here, so I'm going to go ahead and add this to both sides. So now I have a 2y minus x equals y dx dy plus cosine x dx dy. It sounds weird when I say it, dx dy. So used to saying it the other way. So I have all my dx dy's on one side. If I factor it out, dy dx, of course I wrote it the exact opposite way I just said. So I want dx over dy, factoring that out, I have a y plus cosine x, right? And I have a 2y minus x on the left side. And what are we dividing by? y plus cosine x. Divide by y plus cosine x. That is my dx, dy. Now, some of you figured this out already, and you said, hey, Miss Evans, if I'm just flipping this, taking the reciprocal of it, will that not just be the reciprocal of what the other side is? So if I flip, did it simply flip? Instead of cosine x plus y, that's the same thing as the bottom, x plus cosine y. It's the same thing, and 2y minus x? Yes, it is. Most definitely. So if you already know that, if you have already found dy dx, and they ask for dx dy, you can just flip dy dx. You're done. Okay, now I went through the process just to show you. And then their last question, can you find dy dt? Okay, they've told you that x and y are both functions of time. Now, I'm going to pretend I can scroll, and I'm going to take you along with me and probably, maybe, just do this whole problem on one paper. Sorry if you're just tuning in, it's a mess. Oh, but what do I need? I need the problem at the top. I need our differential. There we go. I can see it in green. So here we go. I'm going to take, we've already taken the differentials. So I have a 2y dy minus x dy minus y dx equals cosine x dx. And they want us to find dy dt. Okay, this is what we're looking for. So now how does that work? We have no t's in there. Okay. Second step is still always okay. We're simply going to divide by what? dt. We're going to solve or divide by whatever is in the denominator of what we're looking for. Okay? And then we're going to solve for the dy dt's. So we divide, nothing reduces. Nothing at all. Okay? So we're just going to be looking at our dy dt's and pulling them together. Okay? And again, if you can do this, by all means, please do it. Go ahead and factor it out. I have a 2y minus x, and I need to add this y dx dt to both sides. So those cancel, and we are left with equals cosine x dx dt plus y dx dt. Then do we need to divide? I mean, we really could factor that dx dt so it's just together, which I like that. So if it's okay with you, I'm going to factor this piece out also. So this is really equal to cosine x plus y dx dt. And then we're going to divide by this 2y minus x. 2y minus x. I put it at the bottom. It can go with your dt, but I put it over this one. Either way, your dy dt equals all of this. So dx dt is just your change in x, whatever it may be, volume, or however something's growing exponentially, whatever, based on time. Change in x over the change in time. Okay, so they found the change in y over the change in time is related to all that function times the change in x over the change in time. All right, we're going to stop there. I will do another one to finish up. Great. Hope you guys have a great Tuesday. Bye.